Hi, I'm Dr. Luis Orlando Castro Cabrera. Welcome to this explainer of what has become my life's work at Salus Mundi. We're going to dive right into a biotechnology methodology that is literally transforming the relationship between agriculture, soil health, and our global climate. We've got a lot of fascinating ground to cover, so let's just jump right in.
I really want you to think about this for a second. Have we pushed conventional agriculture to a breaking point where it just can't sustain us anymore? In my years of research, I've come to this really stark realization. Traditional farming models, they've hit their absolute limit. We're trapped in this vicious cycle of extracting more and more from the earth while getting less and less back. The system is fundamentally breaking down.
So, Section 1, the current agricultural limit. Let's look at the macro crisis we're facing globally right now. We are facing a frankly alarming reality out there. We're talking unprecedented climate challenges, severe droughts, brutal heat waves, extreme rainfall, and just rapid soil degradation. Conventional methods, they simply don't cut it anymore. I mean, you can't just keep pouring more synthetic fertilizers onto dead soil and expect a different result, right? Costs go up, margins shrink, and our vulnerability to climate shocks just keeps growing. We need a fundamental, ground-up transformation. And that transformation absolutely has to begin with how we view the ground beneath our feet. My core philosophy here is that soil isn't just dirt, it's natural capital. It is literally the foundational asset of agriculture. And how do we measure the wealth of this capital? Through soil organic carbon, or SOC. That is our measurable indicator. Because when you increase carbon in the soil, you're not just capturing greenhouse gases. You are actively rebuilding the soil's structure, its water retention, its biological life, and its overall resilience to climate extremes. Section 2. The SMRRM methodology. This is the solution my team and I developed to tackle this crisis head-on at a commercial scale. If you look at the evolution of agriculture, we went from traditional organic matter back in the 19th century to synthetic chemicals in the Green Revolution and then to enhanced efficiency fertilizers. But today, I am so incredibly proud to introduce you to the fourth generation, our SMRRM biotechnology. The real game changer here is a breakthrough we call microbial chemoresistance. Simply put, we've developed highly concentrated beneficial microbes that can actually survive and thrive even in tough, high-chemical environments. This means we get an active, sustained biological interaction that regenerates the soil while keeping your productivity incredibly high. So let's look at the core scientific processes of SMRM. It's not about passively adding ingredients to the dirt. It's about sparking active biological processes. Our technology accelerates the transformation and mineralization of organic matter, meaning nutrients are actually mobilized and available to the plant. It biologically fixes nitrogen straight from the atmosphere. It naturally fights off soil pathogens through antibiosis, and it completely revamps soil structure through rhizospheric interactions. But maybe most importantly for our climate, it stabilizes carbon deep in the soil through microbial biomass. It's basically a living, breathing engine of regeneration. Section 3. Real evidence. Let's look at the Paso Ancho validation case. Because theory is great, but reality is what matters. I am so thrilled to share this case with you. We didn't just test this in a cozy, controlled greenhouse. We took it out into the real world under strict commercial conditions in Valle del Cauca, Colombia. For a 5-year monitoring window from 2020 to 2025, we rigorously tracked the evolution of organic matter and soil organic carbon. We wanted undeniable, hard proof that this biotechnology delivers at scale.
And the proof is right here in the numbers. Over those 5 years, we achieved an absolute increase of 0.55 percentage points in soil organic carbon. We went from a baseline of 1.31% up to 1.86%. Now, if you know soil science, you know that achieving a persistent increase like this under actual commercial farming conditions is, well, it's absolutely staggering.
To really put that into perspective, think about the number 21. The Global 4.1000 initiative aims for an annual relative increase in soil carbon that would total about 0.0262 points over 5 years. Our absolute increase of 0.55 points, that means the SMRM system outperformed that international benchmark by approximately 21 times. 21 times! We aren't just moving the needle here, we are completely rewriting the timeline for soil regeneration.
Section 4. Traceability and scientific rigor. As exciting as the data is, science demands strict discipline.
I firmly believe in radical transparency. We have to clearly separate what we've proven today from the complex systems we're building for tomorrow. On one hand, we have our current evidence, our existing biofertilizers products, multi-year field data, our lab capacity, and our intellectual property. That's real, right now. On the other hand, we have our future development, structuring a formal MRV system, measurement, reporting, and verification, integrating satellites, getting independent verification, and eventually accessing carbon markets. We never, ever confuse future goals with existing realities.
And speaking of that existing reality, our foundation of trust is rock solid. We've spent years securing 5 granted patents and 14 patent titles. We've officially deposited 18 microbial strains and 4 complex microbial consortiums. So this isn't just some conceptual idea on a whiteboard. It's a highly protected, rigorously documented scientific platform that we have built from the ground up.
Section 5. The carbon route. Let's talk about how we turn biological success into verifiable environmental assets. To bridge that gap, we have to look at the strict math of carbon markets. You can't just take a percentage increase in soil organic carbon and sell it. A percentage is just a concentration. To move from that to a measurable, tradable carbon stock, tons of carbon per hectare, you have to follow strict methodological rules. You need precise data on soil depth, bulk density, and spatial consistency before you can even calculate the equivalent tons of CO2 removed from the atmosphere. Science demands absolute precision here.
And that rigorous math builds directly into our clear step-by-step roadmap for MRV implementation. Step 1. Diagnosis and baseline through georeferencing. Step 2. Implementation on a pilot plot. Step 3 is technical validation, where we continuously monitor the agronomic response. Once that's validated, Step 4 is commercial scaling across homogeneous soil strata. And finally, Step 5. Carbon monetization through strict, independent verification. We are taking our evidence and scaling it into a fully auditable territorial carbon project.
Which brings us to the ultimate vision of the SMRM platform. We are proving, beyond a shadow of a doubt, that agriculture doesn't have to be a source of environmental degradation anymore. By embracing functional microbiology, we can transform farming into a massive engine for ecological restoration and new economic value. You get to maintain incredibly high productivity while simultaneously healing the soil, capturing carbon, and generating certified ecosystem services. It's a total win-win.
So I want to leave you with this final thought. The limits of the old system are painfully clear, but the science of the new system is proven. The choice is really up to you now. Will you continue mining your natural capital for diminishing returns, or will you join us, adopt this biotechnology, and actually start regenerating the Earth to build a truly climate-intelligent future? I'm Dr. Luis Orlando Castro Cabrera, and I invite you to step into the future of agriculture with Celis Mundi. Thank you so much for joining me in this explainer today.